Yes. So this course, in my opinion, is a quick refresher on the basic topics in data structures and algorithms at a high level. Typically, in most universities, these are like two courses. There is an introduction to data structures, and then design and analysis of algorithms. So we will do a quick refresher at a high level. Um, we will follow a problem solving and bottom up approach. So typically, every lecture will start with the problem we want to solve. We will design algorithms or data structures based on what we actually already know, and then understand the limitations of the existing solutions, and then we gradually move to a new solution. Okay. So this is exactly what I would like you to follow in teaching the course, so that the data structures or the algorithms are not thrown at the students in a top-down fashion. They are naturally evolved, starting from known solutions, understanding the limitations of them, and then we move to a new solution. So you will understand and appreciate the new solution. And okay, I should tell you, by now you would have received 4 set of video lectures and a problem sheet. And of course, I don't expect most of you to have gone through the videos. It's too early because it was just released yesterday. And I'm going to follow this pattern. I mean, last time the videos were released on Saturday and then we met the following week. I think this is better that we will release it on Friday. And so that in the Saturday session, I will get a chance to explain, give an overview of the videos, give an overview of the problem sheet. And then last time I gave 1 week for the problem sheet, but based on feedback, I'm just giving now 2 weeks because you are also busy doing various other things. Again, I chose this time, December, January, based on feedback from most of the teachers that this is a relatively light period between the semester, or the new semester is just going to start. And so you will have a lot more time to go through the videos and understand the problem. So that's the plan for, that's why I chose this time. Yeah. So, yeah, since I am not going to be looking at the chat, if anybody has any question or comments, I recommend just go ahead and unmute yourself and say anything, right? Let me see. Yes. Now, as I said, typically every lecture will start with the problem. We'll move towards better solution. Now, to be able to say, what do you mean by better? Why is any one solution worse than the other? We need to talk about the complexity analysis of the solutions. So that's going to be one of the main themes. Again, based on whatever I have seen, many of you do not touch too much on the complexity of solutions at least in the data structures course. Maybe in the algorithms course a little bit. Whereas here, I would like you to emphasize on the complexity analysis, simply because that is what will answer the question on what and why rather than how. The course focus will be on, so let's say we take an AVL tree, you should ask the question, why do we need AVL trees? What is the feature of the AVL tree? What is it about AVL trees that makes it better than some other simple solutions? You need to know the answer to it. And if you want to know the answer to it, you need to understand the complexity of implementation, the running time complexity of implementations of the algorithms on the data structure. Okay, don't get scared by complexity. Throughout, typically an understanding of order log n is good enough, at least for the data structures course. Again, I forgot to mention there will be 2 parts to this course. There will be 10, 12 lectures on data structures, another 7, 8 lectures on algorithms. Okay. And again, as I mentioned in my trailer mail, our goal is not to complete the syllabus. I am not going to do everything in the modules, but I will touch upon almost every topic and tell you some questions on what and why. Why is that important? What it is? Why is it important? And leave it to you to do how to implement some of this, which anyway you do it in your lectures regularly. Okay, so here is the overview of the first lecture. Lecture 1, I set the terminologies, tools. I talk about what is the data. I mean, I said every lecture will start with the problem. So you need to know what is the problem we're trying to solve. What is the data structure problem? And what is the typical solution, right? This is what is being dealt with in the first lecture. What is a problem? What is a solution? And then we start with this search problem, and we will give some simple solutions. Okay. So maybe at this point, can somebody tell me what is a typical data structure problem? What is the data structure problem? What do you do in data structures?
How to store data so that it can be accessed easily. Like
Exactly.
it require less time, it require less memory access time.
Right. Okay. So for the most part of the course, we are not going to worry so much about memory. We are going to worry only about time. Okay. Now, yes, how do you store or organize data or structure the data? Data structure problem is about structuring the data or organizing the data. Now, what is the data? Data could be set of numbers, set of sets, set of strings. It could be set of websites, various things. That's a data, and you have to organize it. How do you organize depends on what?
The requirement of the application, or for what scenario you're working with.
Yes, more precisely, what operations you are going to perform on the data. So, somebody, I think it was Monica who answered search, access easily. Sometimes it may not be access, sometimes it may be insert, sometimes find the maximum, sometimes delete the maximum. So, you have a collection of data, you want to organize the data, and you want to be able to support some operations. That is a typical data structure problem. Now, a solution will come in the form of, do I use an array or a list or a tree, and how are the values organized? That will be a solution. How do you compare solutions?
The time complexity.
Time complexity. So the solution also comes with implementation of the operations, and then you compare the time complexity of the operation and say which this is better, that's better. Okay. So this is the entire package. If you have a data structure problem, which is data and operations, and the solution is how do you structure it and how do you implement the operations, and you compare solutions based on what is the time complexity of implementing these operations. That's I want you to really register this clearly. You know, this is not about data structures course, it's about any course for that matter. When you start, you need to understand what are we learning in the course, right? Not some jargons and terminologies and so on. Yes, they are needed, but at a high level, we are trying to organize the data to support certain operations. That's your problem. Solution is in the form of an array or a list or a tree, and we compare solutions based on how much time complexity each operation takes. That's it. Once you set the stage like this, throughout the course, every day I will throw you some problem. What is the problem? Data and operations. I tell you, here is the data, I want you to support search operation. Here is the data, I want you to support search and insert. Here's a set of data, I want you to, set of sets, I want you to support union and find. So operations can change, data can change, then you come up with the new solutions, compare the solutions, and see which one is better. That is the theme. That's what's going to happen in the whole course. Okay. So now, lecture 2. So lecture 1 talks about the search problem. Lecture 2 does binary search and analyzes it. Again, I know many of you, so I think maybe I'll do the third. Let me do this slide first. How to use the course and follow the lectures, and then I'll come back to my previous slide. First thing, this is very easier said than done. Start with forgetting whatever you already knew. Right? This helps you
Excuse
to
me,
get.
sir.
Sorry, yeah.
Yeah, your slides are not moving, sir. It's remain in the first slide.
Is that the case for everybody, or?
Yes, sir.
Yes, Professor, it's for everybody.
Yes,
Oh, the
every-
slide is not moving, is it? It's only in the first slide. Okay. You are still in the title slide?
Yes, sir.
Yes, sir.
What about now?
yes, sir. Same.
Same, is it? Okay, let me unshare and share it again. Can you see the title slide?
Yes, sir.
Okay. Now, did it move to the next slide?
Sir, still title slide only, sir.
Okay. So maybe, how about now?
Still title only, sir.
Okay. No change, is it?
No changes.
No change?
Yes, sir. Second slide visible, sir.
It's visible, right?
Yes, sir.
Okay, good. Can you see the second slide?
Yes, sir.
Okay, so you can see the slide moving.
Mm,
No, I
no,
think it
sir.
is still showing
It
what
is
is the course
what is
about.
course about.
Or it's still showing that. Oh my God.
Sir, this sometimes the case when we share the window. If you share the screen, I think the issue may be resolved.
Okay. Yeah, any progress?
Yes, sir. It is
Yes, sir.
visible.
You
Yeah,
see
it is
things
moving
moving?
now. Yeah, it's moving
Okay,
perfectly.
good. Okay. Okay. Yes, so this is something I already covered. I mentioned about complexity analysis. The focus will be on what and why rather than how. So you can see the whole screen, right?
Yeah.
Okay, good. So I'm going to skip this and come back to the next slide. How to use the course and follow the lectures. Okay. So first thing to do is to start with forgetting whatever you already knew. I know many of you are teachers, so you know a lot more than what we will cover in the initial lectures. So get into the mind of the students. Students typically doing this course might have done a programming course, maybe a discrete math course. That's it. So you imagine that's all you know. Okay, so you don't know anything else, and start following the lectures. Now, whatever, use these as starting slides. So you may need to augment with more examples and details from the books as you would normally do. So I'm going to just talk about the initial motivation part of each of the topics. You know, for example, I keep saying AVL tree or heap or something, but detailed implementation, examples, applications, I would like you to augment with me with these slides. If necessary, I modify your curriculum to align with these topics. So I know I will cover about 60-80% of the basic curriculum, but I know there are slight variations in the curriculum. You may want to, when you get a chance next time, the Board of Studies or something, you may want to slightly orient the curriculum to align with this. I think because the flow of what I'm going to do would be very natural and useful. Okay. And more important, participate in the weekly live session. So you can, I know they're all recorded. You can look at them anytime, but it'll be nice if you can, participate, answer, discuss questions. Okay, what are the four lectures, videos which are released? You can see the screen, right? Lecture
Yeah.
1. Okay. Lecture 1 sets the terminologies, tools, and talks about what is a typical problem, what is a typical solution. And we start with the search problem and gives some simple solutions. Lecture 2, I do binary search and analyze it. Again, many of you, well, almost all of you know binary search. You have taught it. But from my experience, very few people can actually analyze the complexity of algorithm, know what the complexity is, or even how to give a proof that it takes order log n. So lecture 2, in my opinion, is very important. Please register and understand it, why it's order log n, and why log n is important. And then I end with the question of, apart from searching, suppose I also want to insert an element in a sorted array, what is the problem with it? Okay. So when I say what is the problem, what happens to the complexity of the algorithm, right? Everything is about complexity. That's how you'll be able to appreciate and understand the new structures. Lecture 3 is a very quick. Okay, can I request all of you to mute? Lecture 3 gives a quick overview of stack and queue, but again, the idea is to get into this mode of problem and solution. You all know stack and queue, just don't omit that slide, because I want you to gear towards the entire course about, here is a problem, here is a solution, here is solution 1, here is solution 2, here is solution 3. These are the performances and which is better. That's how we will run through the whole course. Lecture 4 discusses the problem of supporting insert and delete max. I want you to remember again, you did not know anything. You are a fresh student starting this course. So don't jump into the solutions you already know. Start from the scratch as if you are in the 5th standard, 6th standard, or second year student. And if I throw this problem, how would you solve it? That's how you should look at lecture 4. And I talk about insert and find max. And then we leave open the problem of supporting delete max. These leave open means we will deal with it later in the course. But I want you to sort of trigger them, think about them, and understand the complexity of these additional operations. Okay, so that's what these 4 lectures are. And I told you how to use the course and follow the lectures. Let me just tell you now about the problem sheets. Okay, they play a very important role in understanding, not just in this course, any course for that matter, because unless you attempt understand, do the problems, your learning will not be complete. So problem sheets play an important role. Tests your understanding, helps you to try new problems, gives you new problems for your students. Do them on your own. This is a very important instruction. If the question is not clear, please send a mail. You can send a mail to me anytime. Fix up a time for a discussion if you want. We can have some clarification, various things. For example, the solution is due 2 weeks. So we will have another Saturday where you can ask questions, discuss. So question is not clear, send a mail. But if you are stuck at answers, feel free to discuss with your friends or colleagues. But when you submit, you have to submit your own solution and acknowledge those with whom you discussed. Avoid using internet for solution. There is a certain amount of trust involved. If you do use it, write your own solution, submit, acknowledge the source. To me, this is very, very important. Any violation of this will be dealt with very seriously. You may not get the certificate. You better, you are doing this course on your own. There is a lot of value in thinking on your own. I do allow discussions with your friends, but when you submit, write your own solution and submit and acknowledge those with whom you discuss, because we are very easy pattern matches. Human beings, we can easily catch people who copy. And I really am very, and this is an ethics issue, trust issue. I don't want you to copy from the internet or from others. You can discuss, write your solution and acknowledge. In the case of questions are not clear, you can write to me. No problem. Yeah. Finally, certification, there will be a set of regular problem sheets, almost one every week. And there will be a take-home final exam. So again, it's not a proctored final exam, but I'm going to compensate the proctoring with an individual Viva. So we will have a 15 to half an hour Viva after you submit the test. There I can find out how much you know, how much you wrote things on your own. And you get a completion certificate based on your performance in the final exam and Viva. And if you at least participate seriously, submit most of the solutions, final exam, you will get a participation certificate. Yeah, so that's all I have. Now I leave open for any questions or comments.
Apart from Saturday, which another day?
Yeah, so I thought about it. So let me now do a quick poll. There is chat. Can people press, type +1 in the chat window if this Saturday time is not convenient for you for the session? Whoever feels this is not a convenient time in general, and occasionally I may change it to Saturday or Sunday. Whoever feels that this is not a convenient time, can you type +1 in the chat?
For another day, what you told to type?
I haven't told another day yet. I don't know whether I want to, because anyway, this is going to be recorded, remember? So unless there is substantial number of people who find this inconvenient, well, okay. Because I do want to consider people who did not come today. So probably there are about 100 of them who probably did not feel convenient. So what I will do is I'll send, actually, Florence was supposed to send, but she forgot. We will send a Google Sheet and give a couple of timings for the weekly session. And you can fill it up, and based on that, we will take a call. No, as I said, you can always send me email. Let's see, there is only 2 people so far who have said So Devjyoti, you also did not type 1. So I want people who find the Saturday inconvenient to, because the other option is to do it on a weekday at night. But many of you are teachers, I don't know, and you have a long commute. By the time you reach home, possibly something like 8:30 in the night. One of the weekdays is a possibility. So if sufficient number of people are there, at least maybe for some time I can try both. Okay, so I see 1, 2, 3, 4, 5 people who've said +1 for Saturday being inconvenient. Okay, for a change, can you put -1 people who feel weekday night is inconvenient? I can imagine, especially people, women, lots of other work. Yeah. So as I said, I'll ask Florence to send a Google sheet. Based on that, we'll take a call if necessary. At least for initial days, we may do it on both days. Some weekend evening and weekday 8:30 or something like that, and then we will take a call. Anyway, this is all going to be recorded and played there, so you can watch them as well. Okay, any other questions?
Sir, every time we will receive a Zoom meeting link like we have received this time, or the link will be same for all the meetings?
Good question. I don't even know. Akash, do you know? Akshay? Akshay is the...
Yes, sir. Yes, sir.
Do we use the same link every week, or will you send a separate link?
No, sir. Same link, sir.
So this is going to be the same link for...
Yes. Yes, sir.
For our weekly meetings. Okay. So that answers your question.
Okay. And the timing, sir?
Timing, I told you, I prefer something like this, Saturday evening or Sunday evening. But if sufficient number of you find it inconvenient, we will move it to a weekday at 8:30. Maybe initially both days we will do, and then take a call. Yeah.
Okay. Thank you, sir.
You will get mails anyway.
Okay.
Yeah,
Yeah, go
sorry.
ahead.
So whenever submitting the assignment, so shall we do it on a pen and paper and take a scan
Yes.
copy of it? Okay.
Yes, that's
That
a
is
good
fine.
question. Yes, whatever mode that's convenient to you, that's fine. These assignments are very short, like 3 or 4 problems, as you would have seen. And so about 2-3 pages is what I expect. So you can type it in, put it in, send it as a PDF, or write it in a paper and take a picture or whatever. Yeah. Just make sure that it's legible. We can read it.
Yes, yes, yes. Thank you. Yes.
Yeah. Mohana, are you there? Mohana Priya is a TA for the course. She's a postdoc at our institute. So let me type both our email addresses. Hopefully you have my email address anyway. You're welcome to... So V Raman at... Okay, my chat somehow is not... let's see. Yeah, V Raman at imsc.res.in is my email address, and Mohana at imsc.res.in. Mohana. She will be the TA for this course. So you are welcome to send emails anytime for any clarification on the questions or some points in the videos. Feedbacks are generally welcome, particularly early feedback will help me to correct for future as well. Yeah, thanks, Mona. Yeah, the email addresses are there in the chat window. Okay, any other question? Can you put a +1 in the chat if you are a student? I want to get an idea of how many of you are teachers, how many of you are students. Okay, I mean, there's a huge number of people who have registered, but only very few people have come for this session. Okay, I see this. Okay, so there's Amandeep saying that Saturdays and Sundays are fine, but he prefers after 6. Okay, that's also a possible time. So Amandeep, are you working? You're saying job schedules, but okay. Any other questions or comments about anything? I mean, yeah. Hopefully, you will have more questions next week after you have had some time absorbing the videos and the problems. Make your solutions short and crisp. I don't want pages of answers, but at the same time, they should be up to the point. And this also is a sort of a practice for you to write well. Yeah. Okay, there are no questions or comments, then I'll see you next week. Okay. Which programming language we will be following? No programming language. It's basically a pseudocode. As long as you know any programming language and you are familiar with for loop, while loop, if then else, that's essentially what you need. So in fact, the answers I expect are, if you see the instructions in the problem sheet, typically, just some English sentences are good enough, or you can write it in some sort of a pseudocode or a flowchart kind of things. Okay, thank you all, and I'll see you again next week. Bye for now then.
Okay, sir.
Thank you, sir.
Yeah.
Thank you, sir.